Hi, in this video I will do an example for the d-test or second derivative test for a function with two variables. The function here is fxy equals to e to the power x squared plus y squared, and the question asks for the relative maximum points of this function. Well, you already know that to start with we need to find the critical points. So critical points means that we have to find partial derivative fx and fy and set them equal to 0. But let's see what is fx. Well, fx means that I'm differentiating the function e to the power x squared plus y squared with respect to x. And we know that when you have e to the power of function, the derivative is the derivative of that function, well here with respect to x, times e to the power that function. And here 2x squared plus y squared, the derivative with respect to x is 0, and the derivative of 2x squared with respect to x is 2x, and then we have x squared plus y squared. And fy with the same kind of steps, we find that this is the dy of x squared plus y squared e to the power x squared plus y squared is equal to 2y e to the power x squared plus y squared. Then set these guys equal to 0. This is equal to 0. This is equal to 0. Well, okay, so what you have to notice here that there are two different kinds of arguments here you can apply. The one I like is that there are two factors here, 2x multiplied e to the power x squared plus y squared, and they are supposed to be equal to 0. That means that either 2x needs to be equal to 0 or e to the power x squared plus y squared needs to be 0. But x squared being equal to 0 means that, well, sorry, 2x being equal to 0 means that x needs to be equal to 0. How about e to the power x squared plus y squared equal to 0? This is a fact you have to remember from the section for the exponential function. B to the power any real number is a non-zero. It's indeed a positive number. It cannot be 0. So there won't be anything coming from this piece. The only answer, the solution for that is x equal to 0. The same kind of argument works here, and you get y equal to 0. Well, to wrap up the first part, we know that 0, 0 is the only critical point of f, x, y. Well, that's the first step. The second step is, well, apply d-test. Apply d-test. For d-test, we have to start with d itself. Let me recall what was d. D is, for any critical point given, in this case 0, 0, is fxx at 0, 0, fyy 0, 0, minus fxy 0, 0 squared. So we need to find what is fxx, and then what is fyy, fxy, and then plug in a 0, 0 in those ones, and then form d, and then go ahead and do the d test. Here, let me start with fxx. Fxx means what? Means that we are trying to find the derivative with respect to x of fx. And what is fx? Fx is here. It is 2x e to the power x squared plus y squared. Okay, let me just differentiate this guy here. Well, this is product of two things, so we need to apply the product rule, dx of the derivative of first one times the second one plus the first one itself times the derivative of the second one. And that means we have 2 e to the power x squared plus y squared plus 2x. Derivative of e to the power x squared y squared with respect to x. We actually already found it. It is, you remember, fx was derivative of e to the power x squared plus y squared. We are kind of doing the same kind of work here, and the result would be 2x e to the power x squared y squared. Something that would be very helpful, you see that both of them have the factor of e to the power x squared plus y squared. So let's just factor it out and put here the remaining part will be 2. Here the remaining factor would be 4x squared e to the power x. Excuse me. And that's fxx. And since we are looking for fxx at 0, so let's just put x equal to 0, y equal to 0. So fxx at 0, 0 is going to be 2 plus 4 times 0 squared times e to the power 0 squared plus 0 squared. And here, e to the power 0 squared plus 0, 0 squared, it is just e to the power 0, which is 1. And 0 squared times 4 is 0 plus 2, so the whole thing is going to be 2. That's nice. How about fyy? Fyy is the partial derivative with respect to y of fy. And we know that fy, the first derivative with respect to y, is 2y e to the power x squared plus y squared. And well, do product rule, and then as a result you get 2 e to the power x squared plus y squared plus 4y squared e to the power x squared plus y squared. I'm not repeating the same steps that we did for the fxx here. Okay, so then factor this, you get 4y squared e to the power x squared plus y squared. Then plug in x equal to 0, y equals to 0. Then fyy at 0, 0 is 2 plus 4 0 squared e to the power 0 squared plus 0 squared. This is another number 2. So we found fyy at 0, 0. Now the last step is fxy at 0, 0. So we have to differentiate them, plug in. F for xy means that we find the partial derivative with respect to y of fx. And that means what? We have the partial derivative with respect to y of fx. We found it before, it's 2x e to the power x squared plus y squared. The difference between this and the fxx and fyy is that now we are differentiating with respect to y. The multiple is in terms of x. You can apply the constant multiple rule, and you just get this thing. And well, if you differentiate that, this is exactly same as the fy, the first partial derivative of f with respect to y, which is 2y e to the power x squared plus y squared. And total. This gives me 4 xy e to the power x squared plus y squared. Well, set x equal to 0, y equal to 0, so we have fxy at 0, 0 is just 4 times 0, 0 e to the power 0 squared plus 0 squared, and everything gives me 0. Well, okay, so then D is fxx. Remember, fxx was at 0, 0 was 2, fyy at 0, 0 was 2, fxy at 0, 0 was 0. So it will be 2 times 2 minus 0 squared, which gives me just 4. So D is 4. D is positive. Remember D test. D is either positive, D is negative, or D is 0. If D is positive, then we have to check something else. What is fxx at 0? If it is positive, then we have relative mean. If fxx at that point is negative, then we have relative max. If D itself is negative, which is not what we have here, it will be a saddle point. And if D is 0, the test is inconclusive. So here what happened for us is that now we see that D is positive. Then we go ahead and check what was fx 0, 0. That number, fxx, sorry. fxx at 0, 0, we found it. It is here. It's 2. And it is positive. So this D was positive, then fx at 0, 0 was positive. Then as a result of that, we can conclude that 0, 0 is a relative mean of. It was a little bit long example, but the steps needed to be done here is all as before. We first find critical point, then we found what is D up to here, and then from there we just apply the D test and we conclude that the 0, 0, the only critical point is a relative mean for the